In this video, we will discuss finding higher order derivatives using repeated differentiation. Just like you take the first derivative of a function, you can take a second or third derivative. Technically, you can take an infinite number of derivatives. However, it is rare that you will ever need to take more than a fifth derivative.
I know that the notation for a derivative is f prime, or dy over dx. Is there a different notation for a second, third, fourth, and so on derivatives?
There is. While the first derivative is denoted f prime, or dy over dx. The second derivative is denoted as f double prime, or d squared y over dx squared. The third derivative is denoted as f triple prime, or d cubed y over dx cubed. And the fourth derivative is denoted as the fourth derivative of the function. After the third derivative, all derivatives are written with the numerical value in the place of the prime mark. For example, the fifth derivative is denoted as the following.
So how exactly do you take the fifth derivative?
That's a good question. Let's look at the expression 3x to the fourth power. The first derivative is 12 times x cubed. We can now take the derivative of the first derivative to determine the second derivative, which is 36x squared. We can repeat the same operation to determine the third derivative, which is 72x. And we can repeat the same operation again to determine the fourth derivative, which is 72. Lastly, the fifth derivative is 0, as the derivative of a constant is 0.
So in this case, would the sixth derivative also be 0?
Yes, exactly, because the fifth derivative is 0, taking the subsequent derivatives will always result in an answer of 0.
So are there cases where taking multiple derivatives will not end up being 0?
There are many cases where a function is infinitely differentiable. For example, sine of x. The derivative of sine of x is cosine of x. The second derivative is the derivative of cosine of x, which is negative sine x. Continuing these operations, we get that the third derivative is equal to negative cosine of x, and the fourth derivative is equal to sine of x. Notice that the fourth derivative is the same as the original function. Thus, the pattern of derivatives begins again after the fourth derivative. Following this pattern, we know that the fifth derivative will be equal to cosine of x, and the sixth derivative will be equal to negative sine of x.
Will this continue to infinity?
Yes, the cycle will repeat itself every 4 derivatives, and it will repeat this way forever.